So to carry this forward, I would like to invite you to take place and also invite all other panelists and co-moderators for our next program item, a panel discussing society at risk, so staying on topic, and outlining challenges and priorities in this new space data age. So I invite everyone to come on stage and just take a seat. Thank you very much. So in this panel, we want to connect our societal needs, also a bit the changing political landscape to how we need to respond with tech and also with space data. And with me today, co-moderating, is Peter Kempeneers from JRC, our JRC co-chair and co-creator for BiDS', and a range of experts and high-level political participants from different institutions. And I think we will give the floor to each of you to introduce yourself. So maybe, Georges, you're here, you can start.
Yes, good afternoon, everyone. It's a great pleasure to be here. I'm Georgios Giannopoulos. My name has one additional U. It's a little bit slightly wrong, but it doesn't matter. You get the point. I am the Deputy Director of the Societal Resilience and Security Directorate at the Joint Research Center of the European Commission, and also the head of the Space, Connectivity and Economic Security Unit. You have heard already today by our Director Sabine Hensler that what is the role of the JRC. We provide scientific advice for policy making, and in this particular case we provide support to the development and implementation of the EU space program. In particular, my unit works heavily on Galileo, IRIS², and quantum communications. And also, another unit of our directorate works on Earth observation on the Copernicus Emergency Service. And this, let's say, gives us the opportunity to have a quite holistic approach on the space program, supporting different components of it. And I'm really glad to be here today and discuss some of the burning challenges we have in this area. Pass the floor to the next one.
All right, good afternoon. Rune Floberhagen. I'm head of what's called the Climate Action, Sustainability and Science Department in the Directorate for Earth Observation Programs at ESA. We are one of 4 departments in that organization, which represents about 1/3 of the budget for, of the Space Agency, where the portfolio mainly deals with all the downstream activities, what we do for science, what we do for policy, what we do for the green transition, solutions, applications, service, pre-development in general, and also what we do in support of the commercial ecosystem and industrial competitiveness in this domain. I think that's hopefully short and sweet enough, yeah.
Good afternoon. My name is Jorge Farré. I am the Deputy Director for the SATSEN. Probably for those who don't know, SATSEN is, already has an experience of over 30 years providing situational awareness to the European Union through their top-class professionals. We basically provide geo-int, geospatial intelligence, using space assets, but also collateral data for the benefit mainly of the common foreign and security policy of the European Union, and particularly for the common defense and security and defense policy. So our main customers are SIAC, the intelligence capacity of the Union. Also, we provide support to the missions and operations of the European Union that are deployed all around, and of course to the member states. So we provide foresight, we provide support to decision making, and also supporting the actions, like I mentioned, the missions and operations. We also cooperate with different entities, of course with Commission, where we are the entrusted entity for through Copernicus for the service of support to external action and security, and also in the Frontex remit for the border management. And also with other entities, as for example ESA. An example of that cooperation, long-standing cooperation with ESA is this event, also, which is thanks to this cooperation, and also to JRC. And I wanted to use the opportunity to thank also Latvia for this very generous support hosting the event here. I wanted to mention also that in the SATSEN we have one division dedicated to capability development. So we take care of research and innovation because we think that we need to be at the cutting edge of technology and develop tools which are making the life of our analysts easier. So we care about things like, of course, artificial intelligence, digital twins, and predictive models. And we believe that big data processed through all these new tools that we are developing, that everybody here probably is developing, that will help make the world more transparent, and then as far as security, make it easier for us to protect our society and our citizens. Thank you.
Thank you. I'm just testing which mic is on, but I believe this one. Yeah, so I'm not going to introduce myself again at length because I think that has already sufficiently been done, but just for people who maybe just joined, I have a background in law enforcement with the criminal police in Berlin. That's where I started my career. I studied criminal justice in Oxford back in the day, and back then, you know, at least the term open source intelligence wasn't really a term yet. So I didn't really know what I was going to do with that, but became an analyst and have since moved to the private sector for a little while, where I collaborated with, for example, the European Space Agency in those international research projects, which I just referenced. And I've built a few Intel teams in my time, so that's one of the things I do. And now I predominantly work with international organizations, which was already said. So I think that's enough. I'm going to hand the mic over to you.
Yeah, good afternoon all. My name is Uģis Norītis. I'm the Undersecretary of State for Defense Planning at the Latvian Ministry of Defense. In my everyday work, I more or less cover three big areas. The first is the development of the armed forces, the capabilities related to that. The other one is defense industry and innovation. And the third one, last but not least, is the resource, which is basically the money. So good to be here. Thank you.
Hello, everybody. For those who haven't seen my keynote, I'm Thomas Brunschweiler from IBM Research in Zurich. I'm heading there the AI for Climate Impact team, and we are focused on what's next in computing. So in particular in this domain, we work on large foundation models and how to apply them in the scientific and engineering domain, be it on Earth observation, be it on weather and climate or the electric grid, trying to provide the ChatGPT moment, let's say, outside of the LLM space. And we are very much dedicated to open science. We post our results on Hugging Face, on GitHub. We interact strongly also with university partners and organizations like ESA and other organizations through Horizon projects. So we really hope kind of with the technology we build, we can make a difference, and that's why I'm looking forward kind of to have the discussion here today.
Thank you very much to all of you joining us. So I would say we start right and we get right into it. So Georges, from your perspective and from your work in JRC, what do you see as the most urgent societal challenges, and how do they shape Europe's political priorities currently?
Yes, I think that I will repeat things that most probably many of you have already thought of, many of you have already read and heard around. Of course, one of the major challenges that we face is climate change and the need that we have there to improve our capabilities to understand what is going on through data from space. I think this is pretty obvious, so I don't bring something completely new here. But I would like to highlight things that maybe that are equally important, but maybe not so, let's say, well projected into the media. One challenge that we have, of course, which is particularly important in the EU, is border security. And here, again, the information that we can get from space, from the available assets that we have, but also with assets that will be built in the future, will be critical. First of all, from a security point of view, but also for the links that this has, border security, with migration. And that's another challenge that we are facing in the EU. All these are linked to what we call geopolitical challenges at the end of the day, and the security concerns that we have in the EU. On the other hand, this is also linked with the competitiveness angle. So how we can improve the competitiveness of the EU, of the European economy, making use of space assets and space data and new space economy, actually, how we can make it there. So we have a multitude of crises that we need to tackle. So we have, let's say, a complex multi-crisis situation, which is described by climate change, migration, border security, and so on and so forth. But also, we need to make sure how, at the same time, we can make the economy more competitive using these space assets and space data. Now, if you think about it, all these concerns that we have and the challenges, I leave aside for the moment the competitiveness angle, are very much linked to what I would call situational awareness. At the end of the day, what we need to produce with our technologies, with the data, with the analysis that we do on the data, with the tools that rely on AI to do better analysis, and so on and so forth. It is about giving to the political leaders, to the political masters, the capability to make the right political decisions in the field, but also how they could design better tools and better technologies and better programs for the future. So I would say that one of the key words that we have here is situational awareness. How can we improve that with these assets? And this is what, at the end of the day, drives a lot of political developments, a lot of developments also in the EU space program in the EU. In order to improve this, we are thinking, for example, the governmental service on Earth observation. We try to enhance our capabilities when it comes to satellite communications with FRIARY², which will be part of a bigger ecosystem of space assets, so that we can have, for example, data from Copernicus much faster, with much better revisit time, and so on and so forth. So everything is well connected in order to achieve this, I would say, overarching objective of better situational awareness on the field, to support the operations on the field, but also to support the future development of the programs and take really the right decisions there. And I'll keep it here. And
thank you very much. So from connectivity and situational awareness, maybe back to societal resilience and climate adaptation overall. Rune, where do you see the most pressing scientific and also technological gaps here, using Earth observation and space technology?
So when we look at climate science, when we look at how humanity isn't coping very well with climate mitigation, or is challenged by adaptation requirements, sustainability issues in general. Maybe I'm going to shock people in the audience by saying that perhaps the most urgent thing we need isn't another satellite, but actually that we do the right thing with all the data that we already have. Yeah? So this is something that is becoming a stronger part of the space program, actually, and it changes also quite dramatically the previous or the older philosophy that the job of the space agency were to deliver the data, and by some magic, all the things that needed to be done with this data or could be done with the data would actually happen. I mean, there are good examples, there are many excellent services, there are many excellent applications, but if you compare that with the untapped potential that all these data sets actually contain, I think that we all see that there is a lot more that can be done. So a bigger part of the space program's effort is really trying to, if you will, invite other areas of society, other funding sources, other types of business community that are not operating in the Earth observation domain to dance with us, for us to understand their problems, and then for them to understand exactly what space can offer. So what we are actually doing in this context is to, if you will, unleash our tentacles in many different directions, trying to understand how we can help and support the R&D effort and support also commercial effort in this domain. So this is one area. That doesn't mean, and you should not tell to my bosses that I did not advocate for new satellites, but really this is something that is quite fundamental, because you don't solve the climate problem by launching another satellite. You solve the climate issue by doing the right thing with this type of data. So that's one aspect. When it comes to situational awareness, obviously the situation is quite different, because then you are not relying on basic scientific principles and method, but you really need fast revisit times, high resolution information, multiple times per day, this kind of thing. And in that context, of course, the real need is very different. And this is something that the political level in Europe is addressing these days. It was mentioned, the EU governmental service, and that's one of these aspects. What is happening in Earth observation, in telecom, and also in navigation to support all of that. And this is obviously something that we see as part as well. Maybe one third element, which I want to mention here, that's, everybody knows about this, but maybe not everyone has understood to what extent this is going to become a problem. When we talk about infrastructure for dealing with climate issues, sustainability, environmental science, and international collaboration in this domain, we are actually finding ourselves in a very dire situation. I do not hesitate to say that, but the historical collaborations that we have had, in particular between our side of the Atlantic and the other side of the Atlantic, is not as solid as it used to be. Yeah? And this is a fact that we have to deal with. We don't know how long it's going to last, but the damage for, let's say, the way that the international community is dealing with all of this is something that we really need to take stock of. And Europe needs to provide an answer, at least to make sure that we are developing, supporting our own policy needs, our own independence, and so forth in this domain. And that should also really, besides the science, remain and stay very high on the agenda. Thank you.
Thomas, this is a question for you. We've been listening to your talk, interesting talk earlier today, and I was intrigued by the new way of working with Earth observation, but also big data in general, using foundation models. Nevertheless, it's still a relatively new way of dealing with imagery. And I was wondering if you could enlighten us in how to scale up and what is still needed to entrust the systems. What major breakthrough is needed in your opinion?
It's a good question. Earlier this year in Frascati, ESA organized the joint ESA and NASA Foundation Model Workshop. It was really exciting. Lots of computer scientists met there, talked about the latest and greatest foundation models. Everything looks very rosy. We made tremendous progress. We've shown, kind of with the latest models that we are outperforming the specialized models. So if you have then a generic model, that's much easier to handle, so in operational perspective. But the biggest criticism was like, yeah, okay, you guys have tested those models only on some benchmarking data sets, but not in real life. And also kind of the community from the real life world was missing there. So and we concluded that next time it's urgently important to bring the communities together from the operational side, from the application side, and from the modeling side. So I think that's a lesson learned there. You know, I think it's fair, right? So you have to start somewhere. You have to prove that there's a technical viability. And typically we do this on benchmarking data sets. That's all we have. But then you start overfitting and you don't prove, right? So I think the next step, and I hope till next year, together with the help of ESA and also the worldwide community, we hope kind of we can really demonstrate this. And we also can see that some Horizon programs out there which want to infuse AI into Copernicus services. So now we really have to prove that this is possible. In addition, also we think kind of, you know, we are trying hard, and maybe this is just a sneak peek. We also distilled the models to be smaller even, to enable the proliferation also to space. You know, right now we were thinking about applications in data centers, but now with kind of the distilled models, you can have the foundation models with nearly the same performance also on satellites. We tested this, and the results look promising. So you're a step closer to, you know, software-defined satellites, where then also just small parts of the model have to be updated if you want to use it in a different mission. So I think this would be more like, you know, making models accessible in other domains. And the third element we're also trying hard to contribute to is to make it easy to interact. I mean, originally, most of my team colleagues are computer scientists, but we have to provide tools for the environmental scientists to deal with our applications, or analysts kind of to do it in a no-code environment, for maybe environmental scientists in a low-code environment. So we're working on these pieces, and I think we see steps towards this, and potentially also kind of these agent-based environments would help. And most urgently, I would say, exactly, we hear about the divide across the Atlantics. I think in the open source community, you know, we can see that still we work together. So we have this Earth-to-Back community, which talks about embedding. So it's colleagues from both sides of the planet collaborating on this. So I truly hope, exactly, maybe the common sense, kind of that people and scientists, and they still collaborate even if the world looks a bit different on another level. So I think these are maybe some pieces I believe are important to make this happen.
Thank you. Lynn, a similar question to you. Open source intelligence and Earth observation data are typically fused to assess the hybrid threats we are faced with. In your opinion, what are the bottlenecks we are faced with? What are the major breakthroughs that are needed here? Is it rather, are they technology-based, methodological, or is there more cooperation needed? What's your view on that?
Yeah, thank you. Really good question. And I think that was that kind of ties in neatly with Thomas's, with your reply as well. So I think one of the bottlenecks is definitely that real fusion, technological fusion, is more difficult than it seems, right? So fusion is a bit of a buzzword. I myself used it several times in that presentation. But in all reality, what I have been a part of so far was more the stage prior to that, where you build workflows, right, of what that could look like if methodologies were actually fused. So, so I guess one of the challenges is not so much technological, but it's more methodological, and because we also, you know, I'm a practitioner, so we need to think about what makes sense for the end user and which end users or audiences we're trying to address with that end product, ideally, right? It's all fun and games while we're still researching the topic and while we're playing around and, you know, shifting these steps back and forth. And in those international research projects that I mentioned beforehand, we were very successful with following these workflows of combining Earth observation and OSINT data. But there was still a lot of human intervention, which makes sense when you're thinking about the human in the loop. You know, I want the human in the loop, but ideally I don't want the human in the loop at every single step. I want the human in the loop at the beginning. An analyst has to know what kind of data they're dealing with. You know, otherwise we have the garbage in, garbage out kind of problem. So we need to understand what data we're dealing with, so it's not a black box. And then we also need to, particularly in an Intel analysis, we need to understand the end product. We need to verify the outcome, or else it's not Intel or evidence, or else it's just information. Now, so I think methodology is one of the bottlenecks. Technology maybe used to be one, but it's so rapidly advancing that I think we can hardly keep up ourselves. And I believe that data might be one of the bottlenecks, particularly when it comes to open source information, because in certain, well, let's take SOCM, so social media intelligence. We have so much user-generated content that it's difficult to understand what we're even looking at in terms of the sheer wealth of data. So that can be an issue to denoise that, where automation could also be really helpful. And I think lastly, I'm not going to dwell on that for too long because I mentioned that so far one of the major bottlenecks has been cooperation. But particularly when that is tackled as part of a research project to start out with, for example, I found that very promising. And then, and that is something that Thomas already mentioned, if you're inviting people from the operational domain to participate in these research projects. So for example, law enforcement agencies, or interregional kind of law enforcement adjacent agencies such as Interpol, Europol, Frontex, so on and so forth. Then you have the end user right there with you in the boat, and they're trying to steer the development of, well, that workflow, that fusion, and ideally that end product together with you. So you already have your audience and your users, your end user right there with you.
Thank you very much, Lynn. So zooming in from the international perspective, coordination, collaboration, the wealth of data we have to make sense of. Ugis, so zooming in to Latvia and to the local or national perspective, what societal and political challenges stand out for you, and what does Latvia's growing role does Latvia's growing space sector play here?
Yeah, thank you. Thank you for the question. I think a lot of things what said before, I think also applies definitely for the national level, and what just I think Lynn said, the cooperation, and I think the interlinkage between the different structures within the government. And the question I think we always face is, so is there a need for a central body who governs the, one thing is the space policy, the national space policy, but who tries to coordinate, I don't know, again, I'm a defense planner, who tries to coordinate the specific functionalities or the capabilities different kind of institutions need. Because we did talk, I think some of the colleagues before mentioned that the current threats we are facing, they are hybrid for a reason. Anything which starts as a natural disaster or a crime thing can in turn be linked with something military. We have seen sabotages in Europe, and all of that is again linked with the situational awareness. When it comes to everything, again, not only the military, that's I think what we also try to been doing, not only about the space and about the AI, but nationally, is to talk about the comprehensive state defense, saying that every institution, especially the public ones, of course, in the country, must have a certain plan how to cope with the crisis. And I think it also applies to this area. So each of the institutions have to have a plan or idea, how can they exploit space, how can they exploit the big data, how can they exploit AI. And I think it's, and again, what was also said before, I think we still talk in a way in a different languages when it comes to the public sector, when it comes to the scientists, and then the enterprises, the commercial side of the house. And I think we can always come back to the triple helix model, which is the model without which we can't really talk about pursuing certain strategic goals. We must have not only the fora to talk, but also not to be afraid. I'm coming from a defense and military sector. I think there's a natural reluctance to talk with us because that's something unique and specific. And I didn't see all the presentation, but I came at the end to Lynn's presentation. I think everything shown there is more or less the same way applicable for the military. You see the situational awareness, the intelligence. It's not in a way very different, if you ask me. There's a lot of similarities. So I think we are at the beginning of the way there. I don't know if there is a need for a central body to organize that. I was yesterday having the meeting with our national director of the National Artificial Intelligence Center, and I said, so what we need, for example, for the military is really to show the functionalities which are available. Because by default, for example, the military is rather, I would say, a conservative institution. They don't adopt and accept the technology always as easy. They want products which are tested on the battlefield, which in these domains is not always the case. So I think there's a lot of work also to get everyone on the same page in terms of, even though the technology is not the maturity level we want it to be, we can't avoid it, it's there. And if we are not using, we have to acknowledge and be conscious that our opponents are using that. And I think that's also the biggest risk, is that thinking that we will operate, especially from the defense perspective, in a space environment where we have this superiority or supremacy. I think that's also one of the concerns we have to keep in mind.
Okay, thank you very much. So staying with this and thinking about open data that can be used also for operational services. So Jorge, can you share a moment with us from your experience in SATSEN when space data did make a real difference in responding to crisis and risk, and maybe also what challenges remain from your viewpoint?
I would say everything we do. No, you know, with the new revisit, resolution, flexibility, speed that we are experiencing, the increase of that, it's becoming more and more relevant in many fields for many types of tasking. Maybe one example that would be fit for this event, since we're talking about big data, would be when we have to cover huge areas, geographical areas, as it is the case, for example, with monitoring a ceasefire agreement, for example, where you have to actually, so you benefit from this big span of the coverage of the assets, and then from the fact that also they can have access to areas which wouldn't be easy to reach by ground monitors, for example, or that would be less efficient if done by drones. So that's an example that we have been doing in the past, and who knows in the future. Maybe in the same vein, also the growing complexity of the maritime environment is also a good example, where we are using using power analysis to make automatic detection of vessels, for example, to find something that would be like finding a needle in a haystack, if not in big areas, and then helping in such a way the analysts with the work they have to do. Of course, we are also in this environment. We are also having good examples of using the fusion. We were talking this morning, fusion of different sensors. Like farther than optical, we are using also AIS data and crossing it with RF, radio frequency, and open sources, of course, also. And then with all that, we reduce the work that has to be done and help to track some maritime assets which would be hard if not. So this could be probably good examples.
I would like to remain with you, Jorge, on and look into a crystal ball. In your opinion, if you could name one breakthrough if you could just pick one. In AI, open science, or digital infrastructure, in your opinion, what could really change things in how we use big data from space? And I'm talking about a period of the next 5 years or so, in your opinion.
So I would say it's hard to pick one. I would say that it's the synergy of many of the new technologies in all the chain. So for example, we start with onboard processing, then filtering, then fusion, then the power AI helping the analysts. Finally, some generative tools to provide the final product. So it's the addition of all that, the synergy of all that, that really is creating a breakthrough. But if I had to pick some specific case, probably I would go with what Thomas was mentioning this morning. So basically, the indexing the world semantically in high resolution, I would say less than 50 centimeters. That is probably going to be a breakthrough in the future when it really gets to the level that we are going towards. Yeah. I mean, of course, it has difficulties. It's not only about having models. It needs a very huge storage of data and vector databases, etc. But we are on the way, I guess, and that probably will change radically the way we are working, especially when new constellations, like it was mentioned this morning, the EOGS potential European-owned constellation, where SATSEN is right now performing a pilot on it to explore possibility of governance, etc. So we will have these new assets. We will be for sure we'll be creating really big data, and all those models are going to be helping to make sure that not all the data that will be gathered will need to be analyzed by analysts, which still, I agree with what was said before, the man in the loop is still necessary, but it will allow to focus the analyst into the final part of it, into the real added value, into the so what of what is done, and let the machines work on all that huge amount of data. So.
Okay, thank you. Then Lynn, question for you. In your experience, what is the role of open source data, open science, fair data, in making big data fusion usable for challenges such as early warning and hybrid threat response?
Yeah, good and very difficult question, I believe. So, I mean, there is a stark difference between so-called OSINT as an open source information and OSINT, open source intelligence. While open source intelligence is produced from obviously open source information, the latter is not necessarily public because that is produced via, for example, big data processing, but also together with the subject matter expertise of a team, ideally a team of analysts. And that is exactly that evidence that can hold up in court, for example. So that intelligence product, as I like to call it, that is produced from openly available sources, that is not public. Just as, you know, for example, some very high-resolution imagery, satellite imagery is not public for a reason, right? And particularly when those two latter products, namely VHR or HR and OSINT, are paired, that is when you get a more comprehensive Intel product that is not public anymore, right? So that is produced, for example, for operational agencies or as part of research projects, as I introduced it before. But there are a few words to be said about open source information, so the data that really is public, and collecting that at scale and investigating that qualitatively. So let's go to the latter point first. When I used to work for the Cromwell Police, and I had a person of interest investigation, there's always the question, even though that information that I'm looking at is public, so it's publicly available to everyone, it still relates to private individuals. So that's a bit of a gray zone, right? Does it need to be protected, that information, if it relates to private individuals, right? And then there's the element of proportionality, which ties in neatly with big data processing. So if I collect openly available data at scale, can I fulfill that element, or can I do justice to that element of proportionality still, or not? So I don't really have the answer for that. But that in turn means that obviously if we're in the jurisdiction of the European Union, then data collection at scale has to be proportional, it has to be in line with the GDPR of regulations of the European Union, and obviously maybe national regulations as well, depending on which jurisdiction you're based in. But what I'm saying then, there has to be a reason for collecting that material. If it's for research purposes, it's a bit easier. If it's to roll it out in, for example, an infrastructure or architecture that is part of a product, let's say we have, I'm just dreaming big here, we have an integrated OSINT and Earth observation product where we get both types of information, and then the analyst can operate within the user interface and look at all of that data and sift through it, and we're collecting at scale. So that then means that I need to pay very close attention to anonymizing data, and particularly data that could either endanger individuals, such as, for example, very high resolution, right? So they're the audience that, if we're now thinking about the actual sector where we're trying to sell a certain product, right? Such as maybe the architecture, the product that we developed. In that hypothetical situation, we need to think about our target customer, so the customers that we're trying to sell to. So that will play a big role in terms of dual use, for example. So, and then we have the element of just protecting private individuals' data. So that has to be anonymized, and only for certain questions or investigations, that anonymization could be reversed, right? So that is why, depending on the audience that you're trying to roll out a finished product, if we're talking the stage after a research project, a finished product, if you're trying to roll that out to a certain audience, and let's say that audience could be law enforcement agencies, for example, or military, it's best to have not only lawyers on your team, but also to have the operational partners on your team already, so they can shape that product and that idea together with you. So that would be my answer.
Okay, thank you. Thank you very much. So maybe we stay on the scale of, let's say, civilian systems with open data that is also used for the topics we just discussed, and moving from the civilian spectrum to, let's say, the more security-aligned spectrum. So from your perspective, Uges, as somebody who's working for the Defense Ministry, in what ways do you see both of those systems, also both of those space systems, jointly contribute to civil preparedness? And how are these systems interlinked? And maybe also what, for each of them, does each system play? Like, what role does each system play?
I think you allow the question, of course, as all the rest before and after, probably. I think the first thing is, as I told, I think the recognition of how the modern or the current threats are, I think, very often interlinked. And I think again, the coordination and the cooperation between the institutions by itself, it's difficult, I think, somehow in the nature of institutions, it's difficult to do it, but nowadays that so much data is available there, it's so much noise there. I think it's by default the need is as much there as never before, I think, and I think that's the crucial thing to start by recognizing, I think. Otherwise, if we don't recognize it, I personally love the Einstein's quote about the problem. I actually love it. Because Einstein said if he would have an hour to solve a problem, he would think 55 minutes about the problem, 5 minutes about the solution. From my perspective and coming from my institution, we very often do the opposite. we think about the solution most of the time, not recognizing the problem. I think here the problem is that we do not coordinate, we do not share the data. And I think there is still, coming from a small nation, I think there is a reluctance to not only to talk about the space as something which is there already, the data is available there, but also about the AI. I think it's the reluctance to recognize that those assets are there. And I think we can't neglect it, it's there. So I think the important thing is at the intergovernmental level between the institutions to understand that probably the space and the AI is not the solution, but I think we can't avoid the fact that again the data is there, the tools are there. It takes a lot of effort actually to learn and to use them properly. Again, recognizing it's not, and I again appreciate what colleagues said before. We need a human in the loop as less as possible, still there, to make the applications user friendly. So you don't need to make such a difficult prompts in AI that only 3 people in the institution can do it. But to recognize it, that it's there. You have to know how you teach your people, how you work, how do you coordinate, and who does that when it comes to governmental, I think, institutions. Because otherwise, if we scatter it around, especially again coming from a small nation, the amount of knowledge we have, again, the governmental level is limited, and there is a need to come together and decide who is doing what and who is taking the leading role. Because as everywhere, I think EU, NATO, whatever, if we don't have a leader in that, when it comes to governmental institutions, it's just scattered, we lose the knowledge, we don't have the expertise, and then we avoid the problem, we avoid the tools, and we just neglect it. As long as we can. I'm being very honest and frank with you, but I think that's how it works, not only in Latvia, but I think in most of the countries where the governments are trying to cope with difficult things.
Okay, thank you so much. So staying in the space of, let's say, sharing knowledge, becoming aware of knowledge, becoming aware of what is already out there and what everyone does. Rune, how is ESA, let's say, adopting its EO missions and infrastructures to ensure that big data translates into action?
Well, I think I have already advocated several times, and many with me, data as a strategic asset on par with land, labor, capital, and technology, and we are taking that quite literally in the definition of the evolution of the space program, both at global level, which means in our definition of priorities and agreements at the level of the United Nations, at the European level with the various Directorate Generals and agencies of the European Union, with the member states and of ESA, and by that I mean not just the ministries that put money in our organization, but also other parts of the national governments, definitely. And you can even go lower into regions, to cities, municipalities, and so forth. And we try to create a holistic package to address needs at various levels, from global to local. Obviously, we cannot do everything for everybody, but that's where also this thing of open source, the FAIR principle, and the way that we share and make reproducible all of these environments, they become a fundamental part of the program as well, to make sure that we do not only do example test cases and R&D in support of individual organizations, partner intergovernmental organizations or non-governmental organizations, but also leave those solutions and tools for others to be able to scale and take to market in a different sense. So basically, as I said also before, this is not an easy task. First we have to measure, we have to observe, then we have to understand to generate the knowledge, then we have to be able to see if we can predict what's going to come, then we have to translate and help translate that into decisions, and those decisions into action, and then to the next generation of what we're going to do. So this is obviously a very complex dialogue, but we are seeing, and this is the good news, I think, that we are seeing a lot of support in our member states in general for this type of philosophy, and certainly also from the partner organizations. I can mention two more specific things, going a little bit beyond this general principle. First of all, together with partners in the European Union, the European Commission, we are creating now also business opportunities for European industries in partnerships with industries in other parts of the world. Part of the Global Gateway program, for example, of the European Union, which allows us to set up opportunities for industry in Europe to work with partner industries in Latin America, in the Caribbean, in Southeast Asia, in Africa, soon in South Asia, and in the Pacific, Southern Pacific. So this is just one area where we see new opportunities growing and these partnerships emerging. Another one is how we try to cater to emerging players in this field. Yeah? So of course, we have the commercial programs at ESA, but we are also playing and toying with the idea of organizing as a variant, if you will, of our present open calls. There is actually the opportunity to apply for funding from ESA at any time, irrespective of any particular formal opening. But we are toying with the idea of opening that also for players who haven't really worked in the space domain at all before, but who are interested in all of this, just to see how much we can actually stimulate this community and growth to get new players into the field. So these are just a few examples to show that we take this very, very seriously, and also that we are hopefully successful in bringing this discussion way beyond where space used to go, where we simply deliver data and try to stimulate at all levels of society where we possibly can.
Georgios, as a JRC colleague, allow me to ask you a more difficult question. In Europe, we're quite good, in my opinion, in being at the forefront of research, bringing good new ideas. But I think you will agree with me that we are not so good in Europe in making them profitable, scaling them up. So what do you think is needed, or how come this is the case? And in particular, what can the Commission do to make these ideas profitable and into industry solutions?
Yeah, thanks for this question. I think that's some, not self-criticism, but see things in a realistic way, I think is important in this field. And a lot of things have been said already by the colleagues in this area, but I would say that from the positive side, what the Commission is, or what we do actually, is that we build the infrastructure so that we can have, so that the companies, the private companies, have access to space. So all these efforts that we have been doing in Galileo, in Iris Square, Copernicus, all these are systems that are built with the mindset that we create a motorway which then people can drive in and create added value for the economy. So, in principle, I think that this is a very good way of moving forward, but of course we need to reinforce that. And there are indeed some challenges here. First of all, one thing that I would like you to consider is that if you put together the budget of the EU space program, what the EU is spending as an entity, and what the member states are spending individually on space, if you put all this together, it makes a huge amount of money that could drive innovation if we were not so fragmented. So one of the things that we need to address at a certain point is this fragmentation, which if we go one layer below, because it is easy to say but difficult to do it, it means a lot about how we can build solutions that are interoperable, how we can work on the standardization between the different solutions that we develop so that then they have the necessary access to a bigger market. So that's another thing that we need to do. And while there is an effort, a sincere effort from the institutions to push forward, we cannot do it without some private equity. So we cannot do this scaling up without the help of the private companies who can invest money. So let's say business angels, venture capitalists that invest in space. in space companies. And I can give you only the example of SpaceX. It has created a lot of cash flow for developing their launchers through the Starlink business, which was not core business for SpaceX when they were founded. But by creating an additional service, which is access to internet, they created the necessary cash flow that they need to further develop their launchers. That's an interesting example of a vicious cycle of how you can, let's say, move forward and improve the cash flow for companies so that they can build better solutions. So we need the private sector to be there. But the private sector will not be there if there is no demand. So one of the things that we need to do also from our side is to create the demand for the services. So if we create that, then I'm pretty sure that there will be private equity to invest on companies that provide the solutions that we demand as institutions, but not only governments and so on. And in particular, if this request for demand comes from more than one member state and comes from a group of member states, for example, that would create the necessary scale. So I think that these are the things that we need to think about, and we are thinking about these things I think in the institutions, and I'm pretty sure that we will for sure take the steps to make the situation, to improve the situation here, so that we can commercialize a lot of the great ideas that we have in Europe, because I agree with you, as you said, there is a very good research basis in Europe. We lack the next step, which is the commercialization, and we have seen that also in other fields like quantum, for example, in which we have seen similar evidence.
Thank you. Thomas, the last one is for you. I'm in a good mood, and I have 10 million to spend, and I'll give it all to you, including a team of 10 researchers. Tell me, how would you use it? What solution would you build with AI and space that doesn't exist yet? And also thinking about the scaling up, how would you scale it up?
Thanks for the very generous offer. That's highly appreciated. So maybe we find 10 researchers here in the audience who wants to join. Yep. Okay. So we have, performed quite some advances in AI on the satellite data. We had, let's say, our ChatGPT moment in the weather forecasting world or downscaling. So 40,000x speed-ups with AI models compared to physics-based modeling. We are also exploring now, let's say, what foundation models could do modeling the electric grid. So we are getting closer to societal infrastructure. So, and at the same time also in the Earth observation models, we started including multiple modalities. So in a way, my dream would be kind of moving towards a true digital twin of the Earth, not excluding society. So including society, including atmospheric parameters, Earth observation. So this has to be a holistic system, in particular kind of to do, counterfactual analysis or condition the system. So let's say, initial tests also we did with TerraMind, we have atmospheric variables in now, could you now perform some future forecasting of urban heat islands by injecting land use, land cover maps, which represent the future scenario of an expanding city. So these are some first steps towards this goal of including kind of also society. Because at the end of the day, I think like what Lynn is doing, you're fusing all this data together, it's about humans. Then it's if we look at the uncertainties of climate change, it's mostly about how we as society respond. So it would be super cool if we could inject into the model some legislations and see what the resulting patterns of society would be and the impact on the planet. That could be super cool. The other thing also, we talked about, you talked about kind of all this deep fake and fake news and everything. So somehow my dream would also be kind of if we could ground kind of text to sensors. In a way we see due to the climate change issue, organizations have to come up with reports, and then there's these organizations, consultants telling them, yeah, you should use mostly boilerplate wording, then you're not liable, and but why do we need this text if things could be sensor-based? So, if we would have this digital twin, we could see how the world responds, and also maybe words would be more grounded into true measurements in a way and reality. So maybe a fact checker at the end of the day. So I'm not sure if 10 million is enough. Maybe you have 100 million? We talked about scaling, I mean, nowadays
generous, but not
1 billion
generous.
is nothing, right?
Okay. Thank you. I think we're near to the end, but I would like to finish by looking ahead to BiDS' 2027. And I would like to hear from each of you very shortly, maximum 2 minutes, what concrete technical governance and priorities should we set to ensure that big data from space decisively strengthen resilience, competitiveness, and social security. So what is needed for the future?
And let's not make that 2 minutes, but maybe in 1 sentence each.
Should I start, maybe?
Go for it.
I think I will keep it very simple and short. Following my last intervention, I would say that what we need really is scaling up and commercialization. I think that we have a lot of good ideas and good companies that they need to pass the valley of death and do the next step and become profitable and thrive in the international field, so that we can also solve all these very complex problems that we have, holistic problems. I think that we understand all now what are the challenges. I think we are beyond that. We need really to make the next step and bring all these companies to the next level of commercialization.
I think I will echo that. We have seen in this conference a lot of representatives of the public sector, data scientists, researchers, and also entities that are enterprises that are trying to sell services. But I've not seen many investors and people who are developing the market here. And I think those should be invited to see all the great things that are going on.
Maybe one quick previous comment. I think it's important. We need a skilled workforce. That probably applies to many of you in this room, not only for Thomas' project, but in general, we really need that. And apart from that, from the security point of view, there are 2 points that I would like to mention. One is protection. So we need to all the assets and all the transfer of information is going to be affected by vulnerability. So we need to make sure that we protect it, and then we need also sovereignty. We need to make sure that data is available and its integrity is ensured. It is trustable. So in these current security challenges that we are experiencing, we need an enhanced EU sovereignty and a resilience when it comes to space-enabled intelligence, and that can only be accomplished by cooperation. We need a very strong European Union cooperation. Thanks.
Yeah, I can only agree with that. I think I'm going to keep it relatively short as well. I would like to see some real data fusion pipeline in terms of fusing OSINT as well as GeoINT data in the Intel domain. So that would be great to actually see that in potentially a product prototype. And then in terms of governance, I would like to see just some standardization across at least the Intel domain when it comes to the AI and Gen AI and the interaction with the human in the loop, because so far everyone is kind of doing their own thing. And I guess to sum that up, the success in that realm or in the space that we work in might not necessarily depend on even more data and accessing even more data, but rather being able to trust that data, right? Thank you.
Supplement, I think, what the colleague said before, and what I did, I think, emphasize also before. I think it's the end user at the end of the day who will use it, and to make it as user-friendly and accessible and simple, I think is the key word we have to look. However we try to ramp it up, I think it will ramp it up itself at the end of the day. If it will be so accessible and easy for the user, I think it's just a matter how to structure it and organize it and be able to cope with all the big data there and then make it really accessible.
I would hope for less complexity in terms of how we organize as an organization. I think ESA is quite a structure. Sometimes it's a bit difficult how to navigate, like as coming into this domain. So I think more pragmatism such that we win in speed, and that right now the world is moving super fast, so I think we should be pragmatic and try to be speedy. Yes, that's it.
Okay, thank you very much for all of your insights. This was very, let's say, varied in terms of thematics and topics, ranging from climate to security and defense, from open data used in closed processes, and also thank you very much for the outlook. So with this, one applause for our panelists, and hopefully this sparks more discussion for the coffee break that is happening now.